go through this like relatively quickly. This is what we're getting into next week. But I wanted to go kind of through this with you, so, cause it will kind of help, it'll tie into what we've been looking at with these, absolute values. Transformations, we did them in Algebra 1. And they work exactly the same regardless of the function. So we're looking at specifically like for an absolute value right now, but it's gonna work the same no matter what. So the absolute value of x, the vertex of the parent function is at 0, 0, and then I have a slope that is basically 1 there, right? So our vertex is here, and we have our points that go this side, and then our points that go the other direction over here. Okay, so it looks like that, which that's what we've been looking at all week. Like I said, I honestly don't know why we don't do absolute value in Algebra 1, because they're pretty easy. Although sometimes it's nice just to have something easy. Okay, so as we've been looking at absolute values, I told you to find the vertex. We take the absolute value, what's inside there, and we set it equal to 0, right? And then we solve that for 0, and that gives us the x value of the vertex. And I don't know if you remember or not, but like when we were in Algebra 1, we did like the vertex form of quadratics, and we would write the vertex. So if you remember, like when we factored, like in a quadratic, and say like one of the factors was like x minus 5, we set the factor equal to 0, and that would be x is equal to 5, which means that's where it crossed the x-axis. Y'all remember doing that vaguely in Algebra 1? Okay, so this basically works the same way. If it's inside the parentheses, or if it's inside this absolute value, we're setting it equal to 0, and we solve it, and that gets us the x value. What hopefully you're noticing is like if this is x minus 5, it ends up being positive 5 because I'm going to the other side. So basically, whatever sign this is actually going to end up being the opposite of that when we solve it. Does that make sense to y'all? Okay. So what happens here, and I will write it out this first time, and then every time we'll write it in the shorthand. So this ends up being horizontal, which means left and right, yes. So horizontal, translation, meaning we slide. That's what a translation is. So it's a horizontal translation, and it's going to end up being to the left 2 units, because when I solve that for x, I end up with a negative 2, right? Does that make sense to y'all? Alright, so if x plus 2 inside there moves it to the left, then that means an x minus 2 is going to move it to the right. Is that logical to y'all? So this would be a horizontal translation to the right 2 units. So y'all remember that kind of shorthand abbreviation that I'll let y'all do in Algebra 1, right? Okay, so we're going to use the same exact thing here. Alright, so that's if I'm adding or subtracting inside the absolute value. I'm really going to go take the opposite sign and go really the opposite direction. Good there? Alright, so here I have this plus 2, and it's on the outside, and as we've been doing this week, I was like, well, that out there, it moves it up and down the y-axis. So that is a vertical translation, right? It's sliding my graph. In this case, it's going up 2 units, right? And if it's subtraction, it's going to be a VT down 2 units. Y'all okay with that? Alright, so here we're talking about multiplication, which multiplication, if we think about like a linear equation, it changes the slope, right? So that's the same thing we've been talking about here. As we've had those, I said, well, what's the number in front of x? That tells us the slope. It's the same deal. It makes it steeper or flatter, or with an absolute value in a quadratic, it makes it either like be more narrow or more wide, depending on that value. Does that make sense to y'all? Okay, so those, if I have it more than 1, and this is outside of the absolute value, notice it's not on the inside, it's out here. If it's on the outside, it's vertical. So it's a vertical, it's more than 1. So it is a stretch, and it would be by 2 units. This is also on the outside, so it's a vertical. It's less than 1, so it would be a shrink. The other word they sometimes use is compression. They mean the same thing. Okay, by a half. Y'all okay with that? Y'all kind of remember this both of them, and I want you to have both of them. If I have this negative on the outside, so anything that's not inside the absolute value has been vertical, right? So this is a reflection, okay? So if I think about reflection, it's gonna reflect across this axis and be going down, right? Okay, so it is what we call an x-axis. It's still vertical. It's an x-axis reflection. Okay, if I had f of x, and they don't give you this one, but I like to give it to you so you have seen it, in case they give you something weird. Absolute value of a negative x, and this time that negative is on the inside. And every time something's been on the inside, that's been a horizontal, right? Okay, so if we think about horizontal is left and right. That basically means I'm reflecting across the y-axis. Now when my vertex is right here, it's gonna look exactly the same because it's just gonna flip sides and you're not gonna be able to tell. But if like my vertex was over here and I had a negative on the inside of that absolute value and I reflected across that axis, then that means my vertex would come over to this side. Does that make sense? So it's flipping across that axis. So it's flipping what we would call horizontally to left to the right. Does that make sense? Okay. All right, so that one is a y-axis reflect. It kind of throws people off when we say y-axis because we think the y-axis is up and down, but because it's flipping across it, it's flipping from the left side to the right side. That's what makes it the horizontal. Are y'all good there? Y'all don't see that real often, but I want to make sure that I at least went over it with you when it, if and when it comes up. Are y'all okay there so far? Okay. So what they're giving you, I actually like this side a little bit better because it gives you numbers and y'all do a little bit better with numbers. But they're giving you kind of the generalization over here on this side, which is, and they make this where it can be like a little foldable, and y'all know I don't do that in this, so we'll just do it this way. So if I have a plus something on the inside, and this they gave you a parentheses because it works the same regardless of the type of function. So if we had a quadratic, you'd have a square out here on the outside, right? So if I have it inside of my thing, I'm gonna have a horizontal translation. It's positive, so the opposite of positive is gonna be negative going to the left, and it's gonna be by whatever that h value is. If it's 20, I'm going to the left 20. Are y'all okay there? Hello? Will do. Bye. Okay, so then this other one would be a horizontal translation to the right by h. Y'all okay there? Does that make sense? This one then, it's on the outside, it's gonna be a VT, and it's positive, it's going up because I get to keep anything vertical, I get to keep it as is. So it's going up by k, whatever that number is. This one then would be VT down by whatever k is. Are you okay there? All right, so here, this is our multiplication. So shrink, stretch, basically. All right, so they call it dilation, but it's the same thing. So if I am multiplying by something, a f of x, so this is like this example here, where they use the numbers. So if I'm multiplying and a is greater than 1, then that is going to be a vertical, so v stretch, because it's on the out, a is out here on the outside. So it's a v stretch by whatever a is. This one here still have a on the outside. The only difference is a is less than 1. And so we're talking a fraction here. You notice that that's absolute value. We're not talking about negatives because the negative causes a reflection. Are y'all okay there? This is just basically something between 0 and 1 is what they're talking about. So this is a v shrink by whatever a is, and typically it's going to be, I mean, it's going to be a fraction because it's going to be less than 1 or a decimal. Are y'all okay there? Probably a fraction because y'all know I like the fraction better. Okay, this one I'm going to cut in half also because I'm going to give you both, even though they only give you the vertical. I'm going to give you both of them. So negative is on the outside. Anytime it's on the outside, it's vertical. Okay, so that is my x-axis reflection. If it looked like this, f of negative x, meaning the negative is on this inside of the parentheses, then that is a y-axis. reflection. Same thing I showed you over there on the other side. Alright, so the part that you don't have over there at all, I'm gonna do it down here. If you don't feel like you have enough room, you can write some of it over here. I don't care where you write it. They didn't give it to you, and I wanna make sure that I do. So if I have f of ax, meaning a times x is inside the parentheses as opposed to up here where it's on the outside. Y'all with me? Okay, if it's inside the parentheses, it's horizontal, right? And anytime we're inside the parentheses, something changes, right? It ends up being like that's opposite world. So here I have, like, let's say the absolute value of a, or my number a, is greater than 1, okay? What's going to end up happening, and I'm going to flip over to the back and I'm going to show you what I'm talking about here. So what ends up happening here is, let's say I have the absolute value of 5x here. And remember, when I am dealing with multiplication, I set things equal to 1. When I'm dealing with addition and subtraction, I set equal to 0. But if I'm dealing with multiplication, I'm setting it equal to 1. So when I set this equal to 1, I have 5x equals 1. I divide out that 5, and I end up with an x value of 1 over 5, right? So I basically end up with its reciprocal. Are we okay there? All right, so if that's true, then what happens here is I end up flipping whatever this a value is, and I have 1 over a. Or, I mean, if it was 2/3, it'd end up being 3/2. Does that make sense to y'all? Y'all okay with what I'm saying there? All right. So then, because this ends up being less than 1, and it's horizontal, right? So because this ends as less than 1, it ends up being a shrink by whatever that 1 over a, whatever that reciprocal was. Visually, it looks like a V stretch. They look the same. So visually, sometimes, oh, I'm sorry, I didn't realize y'all can't see that, sorry. They look the same, and a lot of times we really can't tell unless you know some, like, really more in-depth stuff. But these, a lot of times, like, we're going to be able to look at the equation. We don't even really have to worry about the graph because we're going to be looking at the equation itself and being able to know what it is. So then on the other side of that, if I have f times ax, and the absolute value of a is less than 1, meaning it starts out as a fraction inside there. When I flip it over, or take its reciprocal, it's going to end up being more than 1. Does that make sense? Because I'm flipping it over. Okay, so that's going to end up being a horizontal stretch by whatever a is after I flip it over. Because after I flip it over, it's more than 1, which makes it a stretch. This one looks like a vertical shrink. So basically, like I said, anytime it's inside of parentheses, inside the function, inside the absolute value, and it's multiplied, I'm going to take the reciprocal, and it's going to be the opposite of what it started as. Just like the addition ended up being a negative going to the left, it's going to be that opposite. Y'all okay there? All right.